Hey everybody, and welcome back to the Adventures of Blink. I am, of course, Blink, and you can find me on GitHub right here. Now, before I dig into today's adventure, I want to make sure to remind you to click like, click subscribe, click the notification bell, click all the things. I don't want you to miss out on any of the upcoming episodes. I'm hoping that you've been able to follow along with the story. If you haven't, go back and look in the playlist and grab the previous episodes so that you're up to date. This season, we are building a Hangman game in maybe the most complicated way possible. So I want to make sure that you get a chance to explore all the different tips and techniques and tools that we're using because this is sort of a complete look at what enterprise software looks like, but done in a context that makes it easier to get a hold of. So make sure you're following along. I don't want you to miss out. And I'm looking forward to being part of this adventure with you. Okay, so as we dig in today, I thought we'd just start with a quick architecture review, catch you up to speed if you're new to it, or refresh your memory if you've been following along and it's just been a while. So we're going to build a Hangman game, and we're going to build the front end of the game in Python. We've started that process already a little bit. We've built a few pieces of it. It's not quite complete yet. That's what the rest of the adventures are supposed to be about this season, but at least it's something to get started with. Now, what we have built, more or less to completion, is the Mongo database that's running in a Docker container, and the Flask API that's also written in Python that sits in front of it, which is running in a separate container. So we've got two Docker containers that build collectively sort of the back end of the application. And then the front end of the application will be a standalone Python app. All right, so today what we're going to do is connect all the components of our application. We've got the front end code that isn't much done. We have a lot of work left to do there, but we're at the point where we have the ability to run something on the front end that we can connect to the API, and the API, of course, connects straight to the database. So now we can get the end-to-end string of all those blocks, all the little arrows between the blocks on the diagram. We can get all that built and make it work for the first time. And we're going to do a little test-driven development as a way to manage this code. So we're going to write the test first and make sure we can go end to end, and then we're going to write the code that makes it happen for the front end. So where do we get started then? Maybe what we need to look at is how to set up the back-end systems. So let's take a look. So what you see here is Docker Desktop, and you can see I have my application pre-built in here because this is what we did back in like episode 3, I guess, was we made the database and the API, and then we made them both spin up from the same Docker Compose file. So the way that Docker Desktop presents this to you is that you could actually just come right up here and click Start on the overarching S2 Hangman, and it's going to kick off both containers. And you can see they're actually both successfully running, and you could even go test these. So I can drop onto my browser, and I'll show you here. There is the browser is responding, so 27017, the browser is responding on the MongoDB port. So Mongo says, hey, I'm active and everything's working fine. Now, if I were to change this port to 5001, and you can see my history is giving away the secret here. /random is one of the routes that we wrote in our API. And so if I call the random route, then I actually get a response here. And so the hello world phrase pops back in. It's a programmer quote, and all the other details come along with it. So there you go. You can actually see that the application is running. The background application stuff is running. Now, that's what has to be up and running for an end-to-end test to work. Because, as I mentioned, we're doing this end-to-end. So we want to test the front end, talking to the API, talking to the back end. But maybe you don't want to use the Docker Desktop to do all this. You want to do it from the command line. So I'm going to go on ahead and stop these, and then I'm going to drop into the application here. So we can go back, and in our code, remember that we have a Docker Compose file. So I can do Docker Compose and then I can do up dash dash build. And you can now see it kicking off all the things. We're kicking off the Mongo container first, and then we're connecting the API to it. And once you get to the point where things stop scrolling, that means you're active. You can verify that you're active by going over the Docker desktop, and you can see they're both running. So in both cases, I'm doing the same thing, but I'm getting the ability to do one from the command line versus doing it from the tool here. Now, the challenge for us today is that we're going to have to write some front-end code. Now, I've already written this, so we're just going to talk through what we've done. But let's take a look at what it takes to test the database integration. So I imported PyTest because this is just like the unit tests. It's a PyTest. I'm using that library in order to manage my testing. And in this case, I'm pulling in the hangman.db_API. So this is a module that I'm going to create, or you can see I've already created it myself, but this was not here when I wrote this. So you pull in the DB API and you import the class that's going to do the database integration. So I decided that I was going to wrap this in a class so that it would be easy to grab onto when I'm doing this kind of stuff. It keeps the code simple looking, even though a class may be a little more complexity than is actually required to handle the database connectivity. It gives me an easy handle to hold on to when I'm writing the code. So just like we saw in last week's episode, I created a fixture in PyTest, and the fixture is just the thing that's going to spin up the class and initialize everything so that it's ready to start doing work. So when I call DB integration, I've got return hangman DB_integration. That's the class that I imported from my module. Now the next thing you see here on line 8 is a new annotation to us. This is a marker that says PyTest is going to put this test in a group called integration. Now, this means that we have the ability to run multiple command line PyTest calls that operate in different ways. In particular, what we're going to do today is build the integration test to be able to run from a separate command than any of the other testing. Because the end-to-end testing is going to happen sort of in a different cadence. We don't do that literally every time because that requires us to spin up resources. We have to have the database running. We have to have the API running. Whereas unit tests can run much more frequently because they don't depend on all of those other things being active. So test example integration is the name of our test here. And you can see we're calling our fixture. And once we've called the fixture, that gives us the ability to create an API. So the DB integration fixture is going to return that integration class object, which we're just going to call API to work with. And then we're going to assert that API has a random method and its status code equals 200. So if I call the random method from the API, then I'm going to get a status code of 200 in the response. Simple test. Very easy to see how it all kind of works together. Now you may be asking yourself, why am I only testing the status code? Why am I not worried about the actual data? Well, in this end-to-end test, I really only care that the connectivity gets established successfully. I just want to know that it returned a response. I don't know which one, and I honestly don't care. And it's hard to care because remember that we're calling a random method, so it can return literally any object out of the database. I'm not going to know which one it is. I'm not going to have that information to test against. So all I want to know is, did it successfully get data from the database and send it to me? And the way that I can tell that is that HTTP 200 is what I got in my response. All right, so now you see that I've written the test. But what we need is some code that actually runs the test. So DB_API is the module we're going to work in. I'm going to go on ahead and open that up. And we created a class called Hangman DB_integration. That's just a name that I'm putting on there in order to be able to import it easily and tell what's happening in my testing code, and even in the actual application code when we get to the point of building this out. I've got two methods in here. One is the constructor, which just contains all of the setup information, all of the constant data that I want to pass in and make sure is ready to go. So this is how the API knows how to interact. It knows that there's a random URL and an add URL. Now, currently, because I'm only trying to pass the test, I didn't write anything about the add URL. And I'm not going to be doing that in this episode because we're focused on the integration test concept, and I don't want the add URL to be used in the integration. The reason for that is every time I call add, I'm altering the contents of the database. I don't want to do that every time. I want to just use the random one where I can just pull in some data, and that would be good enough because that tells me whether things are connected correctly, where data can flow between them. So the random method is the one that's going to make the call to the random URL. Makes sense, right? But I'm going to use the requests library in Python. This allows me to create an HTTP request. And I'm going to create an HTTP GET. And you can see all the details there of a GET. I'm doing a very simple version of a GET. I don't need a lot of extra detail because I'm not passing auth headers and I don't have any special cookie information. I don't have files or anything that's going along with this. It's simply, I'm going to call that URL and whatever response I'm going to consume. So I pass in the URL, which is localhost:5001/random. And whatever comes back from that, I'm returning to say that was a random request that was made. Now in the future, I'll actually come down here and I'll do a def add, and that one will probably come with some other data, but I don't necessarily know yet. This would ultimately be something like return requests dot post, because I'm posting the data to the endpoint. So I would have to fill in those details and pass the parameters that are required for the post. I'm not going to get into that here, but that's where it would go and that's how it would work. So I'll save that. Well, you know what? That'll cause errors if I save it like that. So I'm just going to replace that with a pass for the moment. And that way we can actually run our test here. Now, the last thing before we run the tests is, like I said, I want to create a situation where I can call the unit tests or I can call this integration test. I don't want them to run at the same time because I want to be able to control which set of tests I'm running. And that was why we had to have the integration marker on our testing here. So in order to make this work, I need to add an INI file to my project for PyTest. I have to tell PyTest how to behave. And so here's the PyTest INI. Just a simple comment at the top here that explains this is pytest.ini, whatever. But when I mark for PyTest, I'm telling it this marker exists. There's one called integration, and it's used to mark a test as an integration test. And it uses this add ops so that it knows how to behave. Now what that's doing is it's telling me that if I don't add an option, then it's going to default to add this onto it. So I can say just PyTest and it will run my unit tests. But if I say PyTests-m integration, I get only my integration test. So let's take a look at how that works. So I can do that, and you'll see it ran and it passed 7 tests, and you see one is marked as deselected. This is the integration test that we just wrote. And the reason it's deselected is because that pytest.ini told it that unless I told it to run integration, it's not going to touch anything that has that marker on it. Okay? But what if I wanted to run the integration test? Then what I would do is pytest-m integration. And you can see in this case, 1 test passed and 7 were deselected. So I'm skipping my entire unit testing set and focusing just on the integration test by changing the command that I run. That's how you do it. And so that way I have control over which set of tests I'm running. I didn't build it into this episode because it's going to take a little bit more work to set up than we have time for today, but this would be a case where I could make a separate GitHub action that would run integration tests. And so it would have to spin up all the containers, and then it would issue the integration test command, which now it has a custom command it can call. So it's a very easy thing to add. The thing that we run into with trouble there is environment variables and making sure that the containers have all the data in them to be able to run and all that. But the short version is that's how you would build this out. You now have control over your test suite so that you can call for the unit tests or you can call for the integration test. And just like that, you can do both. Maybe you do them together. You put them, one after the other, and then you have all the testing in a different path. So there you have it. You now have the ability, using these markers, to create multiple groups of tests that can run at a time when it's appropriate for them to run. This gives you control over how much testing you do at each layer of your development cycle, rather than just blowing all of your time running these tests constantly. Ideally, that would be the perfect way to do it, right? You always test everything on every cycle, but that costs a lot of time, especially as your application grows to the point of having hundreds of tests in the suite. So you may want to be able to pick and choose which things are important to test at certain times. So you may be wondering, Blink, when are we going to actually start doing any of the user interface for our game? And I have some really good news for you. That starts next week. So make sure you tune in as we'll start building the first screen into our application's UI. This will be a chance to maybe do a little bit more coding and a little less talking about test-driven development principles and things like that. I do hope you're enjoying the process of learning how to do all these things. This is really an interesting part of software engineering for me. Anybody can find a way to write a program that does a little whiz-bang interesting thing. But I think the real excitement of software engineering comes in the ability to automate tasks that help you move the ball forward faster. And that's what things like TDD do. That's what things like test automation do. And I think it's really exciting to watch these principles in action on a small scale where you can start to understand all of what's happening there, so that when you apply it in the larger scale, it makes more sense. I hope you're enjoying the build. I hope you're building along with me and learning a lot. And I can't wait to see what you do with it. We'll see you next time.